All right. Okay, you can hear me okay? Yeah? Cool. Good morning. I have I am like super excited to be here because yes, you've been asking me for so long. I feel so very honored that you've been pestering me because like I'm just so happy to be here. I love regional conferences so much, and I didn't know that PyTexas was like the oldest regional conference. Yeah, so I'm just excited to be here and to meet you all. So I don't sing technical keynotes that often, but when I do, I thoroughly enjoy them. I'm not sure if this meets the bar of keynote level, but I really like this talk, and I hope you do too. I even learned Blender to make this cool slide. So yes, hi, my name is Lynn Root. I'm Rogue Lynn, like everywhere except for GitHub. I'm econ chick on GitHub. I don't know what happened there. Yeah, you can find me on Mastodon, on Twitter, on Instagram, wherever. Yeah, and I am a staff engineer at Spotify, and I'm based in New York. I've been at Spotify for over 10 years now. And most recently been working on infrastructure for ML, experimentation, and governance. I also actually teach at Columbia, which is a rather new gig. But yeah, you might also know me from PyLadies. I am the chair of the Global Council of PyLadies, and if you want stickers, you can come find me for stickers later. And yeah, as a heads up, I'm not doing Q&A, like live Q&A session, but yeah, I'm just honestly too nervous to be up here and actually hear questions, even if you know, are loud enough. I just can't physically hear people when I'm up here. I'm super nervous in these lights. But I'm more than happy to chat afterwards. And for virtual folks, I will like hop on Discord later and answer anything. But yeah, let's jump to it. About 10 years ago, I bought an electric kettle from Breville. It had this plug and it like blew my mind. I found myself asking, why don't all plugs have a fan like this? It's probably because of patents. Um, but not only does it make it easy to unplug, like you don't have to wiggle around, try and get leverage, maybe like electrocute yourself. But it's also very easy and obvious to me how to use it. It allows for easy grabbing and pulling, right? So the simplicity and the thoughtfulness of this design just made me think, what else am I unknowingly struggling with? This brought me to this book, The Design of Everyday Things by Don Marvin, which you might notice is the inspiration for my talk's title. And it's got this like nice coffee pot. It's dubbed the coffee pot for masochists. And the premise of this book is how design serves as the communication between object and user, and how to optimize that communication for a better experience. So Don Norman writes, design is concerned with how things work, how they are controlled, and the nature of the interaction between people and technology. The range of things is not limited to physical objects, like the Breville plug that I'm so in love with, or the masochistic coffee pot. Um, it includes, artificial creation as well, like software and digital interfaces, or like the layout of a conference room, organizational structures, whatever. So what then makes design good? Donnan says, two of the most important characteristics of good design are discoverability and understanding. And so breaking this down further, discoverability is described as, am I able to figure out what actions are possible and where and how to perform them? So the author lays out 5 key elements of discoverability. The first one is affordances. So affordances determine what actions are possible. It's what a user can do with an object based on their capabilities. Affordances aren't a physical property. It's the relation between the user and the object. So a door affords opening if you can reach the handle. So for a toddler, a door doesn't afford opening if they can't reach it. So building on top of affordances, the second element is signifiers. A signifier is some sort of perceivable cue about the affordance. So signifiers communicate where the action should take place. The term signifier exists in this context to make a clear distinction between the signal an affordance might provide to a person, which is entirely in the visible, perceptible part of an affordance, and the actual affordance itself. So they are like signals, they're labels, sounds, some sort of like physical indicator. So for example, a flat panel or like a bar on a door would signify that you need to push the door open. The third key element of discoverability is constraints. Constraints are limitations or restrictions, and they give us clues that allow us to determine a course of action by limiting the possible actions available to us. There are a few types of constraints. They could be physical, like a mailbox slot that only allows letters instead of packages to be dropped in. Or it might be logical, like where the last piece of the puzzle might go in to only the last space left. And then there's also like cultural and semantic constraints, where like a red road sign typically means stop. The fourth is mappings. A mapping is the relationship between control and election. So when a mapping uses spatial correspondence between the layout of the controls and the device being controlled, it's easy to determine how to use them. So a good example of a good mapping would be where you'd have like two lights and two light switches, and then like the left light switch would control the left light, and the right light switch would control the right light. I have a couple of bad mappings in my own apartment that I should try and fix, but it's really annoying when they're not mapped correctly. The final key element is feedback, where the results of an action is communicated back to the user. So feedback should communicate clear, unambiguous information back to the user in order to be effective. Immediate feedback is ideal. Delayed feedback can be disconcerting and lead to a feeling of user abandonment or failure. And then there's a delicate balance between the amount of feedback. Too much feedback can be annoying and irritating to the users, or too much to even like want to read through it all. Too little feedback could be useless and as good as no feedback at all. And then feedback also needs to be prioritized. So you have important messages and alerts versus like unimportant messages. And so these are the 5 key elements of discoverability. We have affordances, signifiers, constraints, mapping, and feedback. And they help build up to the second part of good design, understanding. So understandability, it means, is it possible or easy for users to figure out how the product can be used? So understanding is developed by forming a conceptual or mental model of how something works. A conceptual model is just a collection of explanations, often pretty simplified. And so the user builds their own conceptual model of how a system or product works, and the designer designs the system or product using their own conceptual model. The designer expects the user's conceptual model to be identical to their own, but it can't because they cannot communicate directly with the user. So the burden of communication is with the system and its design. So good conceptual models are the key to understandable, enjoyable products. And good communication is the key to good conceptual models. And then that communication comes from those key aspects of discoverability, the affordances, signifiers, constraints, mappings, and feedback. And so maybe you can start to see how these ideas, essentially human-centered design, can start to apply to software, to designing a library for others to use. My first instinct when thinking about this is to think about libraries that I've worked with, maybe that are not so fun to use. I'm not going to, name and shame any Python libraries here, but there's one non-Python library that I do loathe. It is FFmpeg. you don't know, it's a well-known CLI tool. It's designed for processing audio and video. So this screen recording is just me running a command list to just list some documentation. And so whenever I use FFmpeg, the ways for me to figure out how to do something seemingly simple, like creating a looping GIF from a video, I end up needing to go copy commands from Stack Overflow because I'm sorry, the documentation sucks. Uh, it's so powerful, and I know that I can do many things with it, and I will continue to reach for it just on its ubiquity and its performance. But there will always be this reaction. So this made me think, if I am an engineer who develops tools and infrastructure for other engineers, how many masochistic teapots have I unknowingly shipped? How many sighs have I caused? So there are much, much better people to give talks on this with better ideas and theories. So I'm not an authority on API design, but for me, there's a missing connection between a theory of good design and the actual implementation. So this brings me to my talk. I'm not sure if anyone else has seen my previous talks, but I have a habit of writing talks for myself, particular ones that I really wish I saw years ago. So this talk is mainly for Pathlin that tries to take key elements of good design and apply them to a real-world example. So I was able to condense this into 3 tenets or 3 key principles that make a delightful to work with API. So first, I'm going to set the stage. In a previous talk of mine, I went through building what's called like a chaos monkey system, and it uses a pub/sub queue. I kind of want to stick with that theme. And so let's design a library that works with a pub/sub queue like service. I'm just going to call it a chaos queue, because why not? It has nothing to do with this car. I just like it. All right, so let's look at some code. So first we have this class that defines a message object. And all it does is contain data to be passed to and from a chaos queue. And we have a second class, a client that essentially publishes to and consumes messages from our pub/sub chaos queue. And so this is our starting library. Perhaps you are already thinking of some things that you want to change, which is great, but just hold tight. In order to develop a little bit of empathy for my future users, I want to write a little bit of user code that interacts with this library. So on the user side, I have a pub/sub queue client, and then I try and create a topic, create a subscription as well, and then catching if they already exist and continuing on. And then we start interacting with our client. We have a silly loop that publishes 5 messages to a grass pub/sub queue, and then a while true loop to consume those messages. We print the message, maybe it's some leftover debugging, and then we do some sort of processing on the message data. And then we acknowledge the message from the queue when we're done processing. And then finally, maybe the client has some network connections that we need to clean up and close, or some buffers to flush. So this is what we have. So let's improve this for the user and start iterating on our library. We'll start with my first of 3 principles. An API should be intuitive. And note that I mean intuitive for the user, not for you, the implementer or maintainer. So with an intuitive API, a user can be lazy. They don't have to think too hard about how it works. They need to remember complicated details because their intuition correctly explains it to them. They don't have to spend a lot of time learning new parts of the API because they all work pretty similarly. And so an intuitive API builds on the user's pre-existing conceptual model and tries not to do anything surprising, nothing that unnecessarily works against any logical or domain constraints. And so with that, I have 3 changes that I want to make to our chaos queue to improve the intuitiveness of the API. So we're going to start with some low-hanging fruit, and naming methods in our client class using the domain's nomenclature, like publish a message, file a message from a queue, acknowledging a message is complete, and drain a queue of messages. So right now, we have add message, get message, mark message done, and clear message queue. And so we're going to name to publish, file, back, and drain. Now, I also dropped the noun from the method names since I found them a little redundant, particularly because in my relay, the noun that we're operating on is in the function signature already. It's the message. And then now look, I have room on my slide to indent 4 spaces in the 2. So why are we doing this? So this plays into the mappings element of discoverability. Naming your functions something similar to the domain that they're supposed to work in can help result in immediate understanding of what your API is supposed to do. So the next suggestion kind of steps back a tiny bit to think about appropriate abstraction levels. So clumsy naming hints at clumsy abstractions. Within the slide's kind of a little clumsy. If you recall our PubSub client, we have a few curious methods. We have create topic, create subscription, and close client. But this client seems to manage a lot in one object. From the user's point of view, what if we want to just consume messages and not publish them? Do I have to create a topic for some reason? Or will there be multiple connections managed by the client, some unnecessary? So let's not add any unnecessary confusion to the user and break up those client into 2. So one that works with just publishing and one that works with just subscribing. So this allows us to clean up the method names a little bit as well. And then this creates natural constraints on what the user can do. If the user must create a topic, then they have to instantiate a pub client and are limited to only those actions provided with the pub client's methods. However, our clients also create some unnecessary constraints on our users. So that brings me to my quick change. Let's make sure our API has symmetry. So we allow the user to create a topic or create a subscription. Well, what does the user do if they want to change an existing topic or subscription or even delete one? So let's not limit them unnecessarily and provide symmetry with our methods. So just having a create method without its logical symmetric pair or triplet or whatever gives a misleading signifier to the user. You can be certain that users have worked with other APIs that provide both a create and a delete method, a set and a get method, an upload and a download method. And so it would be counterintuitive to either not provide such functionality or to provide that functionality, but not follow convention in symmetric naming. So some of these changes may seem a bit contrived. It is really hard to come up with a simple, succinct example that is also relatable, but hopefully the message is starting to come across here. And some of these changes later on in the talk could very well apply with being intuitive. And I'm sure the changes that I'm not even addressing here may apply. And again, I'm not really an expert here, but anyways, let's move on to the next tenet. An API should be flexible, and again, I mean flexible for the user. It's a whole other talk about writing flexible APIs for maintained by contributor. So basically, a flexible API lets you do what you want. In my point of view, a flexible API lets users to get started quickly with the more basic use cases. And then it allows the user to adjust as they need to solve more and more complex problems. So flexibility comes down to the question of how many problems can users solve once they learn the API. So for this tenet, I have 4 changes I want to make to a chaos queue. The first is to provide same defaults to the most common use cases. So recall that we have some methods that work with publishing and consuming messages. The main resource these methods are working with is the message. The timeout and the retry arguments aren't required to the core functionality of publishing, pouring, or acknowledging a message. And then I often find myself as a user to not know what a good number of seconds a timeout should be or how many retries I should be making. And so as the API designer, I should make optional behavior as optional keywords with some defaults. So maybe 30 seconds is the most common timeout value, or maybe it comes from the default of the server side. And then maybe having a 0 as a default for retries makes sense too. So by moving a lot of optional settings into keyword arguments, it allows the user to focus on just what is required of them. This change also goes a bit beyond the flexibility of an API. By forcing users to use keyword arguments in providing same defects, we limit the number of and the order of positional arguments that the user has to remember. So for instance, both timeout and retries are integers. If they were positional arguments like before, the user could easily inverse them when calling the method, and then that would safely pass type checkers. We even have more optional keyword arguments in our methods, like request ID, velocity level, maybe a bunch more. If you have many arguments, positional or keyword, you might want to step back a little bit because it might be providing another hint at clumsy code. You might be unnecessarily exposing some complexity. So with type hints and a lot of arguments, if folks can't understand type annotations, maybe you need to rethink and refactor. So for the sake of my slides being readable, I'm rolling all these keyword arguments into star quads. But don't do this at home, particularly for your public API. For like libraries with like automatic doc generation, instead of finding a list of arguments and their meaning in the documentation, users will absolutely see no information about the vague like some keyword arguments. And then if the library does not have like automatic generation or any documentation at all, which, shame on you, but then the user can actually just simply look at a function signature. You must dive into the code base to try and understand what these quarks are. So again, these quarks are just to make my slides readable. Anyways, moving on. The next change I want to make is to increase flexibility of our APIs to minimize the user's need to repeat themselves. So we saw in the user's code a loop for publishing each message. So in the PEM client, our publish message has one positional argument for message. To minimize forcing the user to repeatedly call publish for each message, we can accept multiple message arguments in the function signature by collecting them into star args. And then we can do the repetitive work for them. So hopefully you're writing some user code as you are building your API. Since while doing so, you can look for common patterns in the user code that you could minimize away, like loops and repetition. Then, as I said earlier, the tenet of flexibility is, again, from the user's point of view, right? Providing flexibility to the user requires you to be predictable and to be precise in what you do for them. So if we part of building that conceptual model, that understanding for the user is providing constraints and feedback. So we provide flexibility in what we accept as input, but there needs to be a clear constraint in what we try. We shouldn't make the user figure out what object type that they get back from a method of ours. So we'll call our subscription client that returns a consume message when we call pull, or it returns none. So this doesn't seem too predictable or too precise. So the user has to check if they got a message at all or if they are dealing with none. So now what's the none use case here? It's when there are no more messages in the queue to consume. Now, if they look at pre-existing APIs like the Python queue library, it raises an error when the queue is empty. That seems pretty reasonable to do. So let's update our function signature to only return a message object. and then raise if there are no more messages in the subscription queue. So this goes back to with what Don Norman was saying about feedback, that it should communicate clear, unambiguous information back to the user in order for it to be effective. So this last change of flexibility, it was kind of supporting the users being lazy. Basically, not force users to provide data that you can generate yourself. So recall our message object. It has an ID, it has some data, and it published at timestamp of some sort. Now, when creating a message, there's no need for users to supply their own unique ID. They probably shouldn't even be handling that, or even to timestamp it when it's published. We can do that ourselves. Now, we probably would not have a timestamp be generated at the time the message is instantiated, probably when it's actually published. Coming up with real-world examples is kind of hard. But now let's say we have a bit of user understanding. So often a user might want to print or log the message for debugging purposes. And for that, we should provide a wrapper method to make it easy to just print out the instance. So now the user doesn't need to worry about printing necessary attributes on the message, but just the message itself. So this is just one approach at redefining our message object to help out the user. We could also use data classes. This removes some boilerplate for us. It does get a little clumsy with setting defaults in our case with post in it. And yeah, the code kind of goes off the slide a little bit, but it's still nice. A third option would be to use the third-party package adders. This actually allows me to go back to the force-based implementation. But also, if I need adders would provide me flexibility and constraints for my users, since not only does it give me a clean way to set dynamic defaults, it also has validation and convertives and even the ability to abuse in it more so if I need it. Now, I'm not a paid shill for adders. I'm just a happy user of it. So if your API is not flexible, you'll find yourself saying, I'm sorry, I know our API should be able to do that, but for reasons that you don't care and that are within our control, we can't. So if the API is not flexible, users will eventually ditch the library and go to something else that does solve the problems. And so for my last tenet, an API should be simple. The complexity of an API can be measured by the cognitive load it requires to actually use it. Complexity hurts our understanding. So we've already made some changes to reduce the cognitive load of our API, like consistent and appropriate method naming, limiting the number of positional arguments in our function signatures, and minimizing the amount of repetition that the user has to do. But we can make a few more changes to make it more simple. So the first change is to provide composable functions. APIs that follow the mathematical closure property tend to be simple as well as flexible. So loosely, an API holds that closure property when every operation returns a data type that can be fed into another operation. This means that different operations in your API can be composed with each other. For example, in Python, we're able to chain a bunch of string methods together since the output of many string methods is another string. So the closure property makes it easier to combine multiple operations to get the desired result. Maybe users don't do it that often, but following this wherever possible allows users to not have to remember differing function signatures operating on the same object. So looking at our subscription client, we have 10 methods that operate on the message that they act. And it's pretty reasonable to think that once you pull a message from the chaos queue, you'll want to acknowledge it. Otherwise, it'll just get redelivered after some time, and then you have unnecessary duplicate work. So there is no reason for us to be restrictive in our function signature for acting and requiring a string, but adds to the cognitive load for the user. They basically have to remember that they must give an ID of the message and can't actually pass in the object that they've been working with. So let's change that to the message object, and we can figure out how to. This is someone else's phone here. You should figure out how to get the idea of the message from them. And so now it's simpler for a user to pull a message from the subscription and then hack it. So while we're at it, let's also accept the ability for users to give us multiple messages if they wish to batch up their acknowledgments. It certainly adds to the symmetry of our method signatures and also removes unnecessary loops in the user code. Now, while we're on the topic of loops, the next change I want to make aligns our API with some Python idioms, making it more Pythonic. Now, leveraging language idioms also leans into what a programming language affords. Different programming languages allow you to or afford you different approaches to solve the kinds of problems that we solve. So, like supporting reflection and introspection, or supporting default values for the function parameters, or how to define an iterator. So, looking at our subscription client again, the user has to call pull to get a single message. And then you might recall that in our user's code, there's a while true loop. So let's make that easier for the user and provide an iter method that returns an iterator. So providing an iterator is helpful for cases like this, where the user is consuming a stream of events or data. It's also helpful when users might need to page through results, like a search query with hundreds or thousands of items. This iter method also happens to simplify the user's code even more. The iterable just stops when there are no more messages. The user can now remove a try and accept around for empty queues around the consuming code. So in continuing on leveraging the language idioms, you might remember that both clients have a close method, managing any connections and buffers underneath the hood. So this forces the user to remember to clean up after themselves, adding to the complexity and cognitive load. You might see where this is going. Let's make use of a context manager and provide an easy way for users to not have to remember any finalization or cleanup behavior. And then there is a third adjustment that we can make to align with existing idioms and habits. We have two create methods in a pub and sub client that the user would have to put a try and accept on, because it loses if the topic or subscription already exists. So let's follow the convention of other APIs like os.migdir or even SQL's create table, and allow the user to not care if something exists already, and just make sure that it does exist. So we'll add an exist OK keyword that'd be a boolean, and we'll default it to false, since it might not do what the user expects. So we'll kind of force them to opt into it. Now, so the last change, we can also think of simplicity as, is it convenient to get started? How much do I have to learn to start being able to use this library? What do I have to do right now to get it working? If an API is not convenient, if it takes many steps to get started, or I have to page through a lot of documentation in order to get a very basic understanding, then the tool's adoption will suffer. So provide your user with convenience. And you can do this by treating your README like you would a newspaper. So give them the most important details first, like above the fold. And then if users want to learn more, they can turn the page, or they can read the rest of the README document or other docs. And so when I'm looking at a README, I want three things above the fold. How do I get your library? Do I need any system level or non-Python dependencies? What are one or two examples that I can copy and paste immediately to try this out? And as a side note, potentially reconsider if your examples are using the repo or like having like the bash like prompt. It makes it really annoying to copy and paste those particular examples. Maybe that's just a pet peeve of mine. And then say, where can I go to get more information? So give me those three things at the top, and then I'm good to go with getting started with your API. So creating a simple API is all about reducing cognitive load on the user, reducing what the user has to keep in their head while working with your API. All right, that was a lot. I'm going to rewind and review a little bit. So we started here with a very simple API for a library that contains only 2 classes. As we went on, we built our code into 3 classes, and now this slide is unreadable on purpose. And that's okay, because we started with a lot of user code, 29 lines to be exact, and got it down to 14 lines. Now the code can actually fit on the slide and be readable. This should be the goal, not necessarily the number of lines of code or if it can be on a slide, but it's about user empathy when designing a delightful API. And so to recap, is your API intuitive for the user? Is it flexible for the use cases? Is it simple enough to essentially learn once? So you have to keep in mind that your software will become a part of a larger system. Your only choice is whether it will be a well-behaved part of a larger system. The how can be a little elusive. So hopefully this example progression in improving a dummy API was helpful. It's a lot. All right, I understand. So if you only remember one thing from this talk, besides, my awesome cheeky synthwave theme, is to remember this. If all else fails, standardize. So Don Warren leaves us with a good catch-all. When no other solution appears possible, then design everything the same way so people only have to learn once. All right, so that was all I had.